yesterday's class? কি পড়ানো হয়েছিল? Research, the steps, তাই তো? So we'll focus on a specific part over there, that is basically analysis of data. This is also known as statistical methods. Now, why is any of this necessary? Why is any of this necessary? কি করতে যাচ্ছিলাম আমরা? What are we gonna do? First, we are gonna examine get a population. We have a target population, and there we are gonna study a prevalent scientific scenario over there, right? Say a disease is X% prevalent in a certain population, right? A disease is X% prevalent in a population, correct? So how are we going to come up with the number X? How will we come up with the number X? Or how will we state the fact? To come to the number X, or to state the fact, we need to study the population. How will we study the population? We will gather data from everyone, then analyze the data. The tools required are collectively known as statistical tools. Understood? Everyone? Let me give you an example. A medicine X is 70% effective. How will we come to the number 70? If it is 70% effective, it must be effective for everyone, the whole population of the earth. We can't go to everyone, right? What can we do? We can draw a sample, administer the medicine to the sample, see the changes, note the data, analyze it, and then interpret things about the population. Understood, everyone? So that is the thing. So statistical analysis is of two types. One is descriptive and another is inferential. Now, what is the difference between these two? Say we have a population of 1 lakh. We can't go to everyone, correct? What can we do? We can draw a sample of 100. Drawn a sample of 100. Now what can we do? We can find the mean, the median, mode, SD, standard deviation, variance, etc. Know these things? Heard of them? These. What are we doing out here? Or maybe we can draw a diagram, represent this in a diagram. Or we can do a tabular representation, we can do frequency distributions, all know. So what are these? We are basically describing this 100 people, correct? It has nothing to do with this 1 lakh people, right? We are just describing this 100 people. This type of analysis is called descriptive analysis. Understood? And what are we gonna do with this? This won't make any sense. This medicine was 70% effective on this 100 people, correct? Say we have come to this conclusion. What will we do with that fact? It was effective on the 100 people. I need to establish the claim for the population, right? So what will we do with this fact? Nothing. We can use this to interpret things or draw inferences about the population, correct? That route map is called inferential analysis. Understood? Everyone. So under descriptive statistics, what do we have? We have tabular representation. Which includes frequency distribution. We have diagrammatic representation. We have central tendencies. What is central tendencies? Mean, median, mode. In this we are just finding an average value. There are different types of averages. One is a mean, one is a median, one is a mode. I'll explain these later. But first know what is there in our scope. Then we find the dispersion. What is that? SD, variance, range, etc. And finally, in certain cases, not always, we find the skewness also. I don't think that will be necessary in our project, but okay. And kurtosis as well, but those are not necessary here. And inferential statistics. There is basically two methods of inferential statistics. One is inference, estimation. And another is testing of hypothesis. Now what are these two? Say we find the average to be, say not this problem, any non-random problem. Say we are finding the average height of the population, correct? We find the average height of this sample to be 160 centimeter. So after analyzing this thing, we come to a conclusion that say the population sample average is 163 centimeter. What are we doing? We're just coming to a single point. Like we are exactly coming to a point. We have no idea beforehand. We just had this and then we use this to come to this. Correct? This type of inference is called estimation. We don't have that in our syllabus. Understood? What do we have? We have testing of hypothesis. What is that? We first give a claim. This is called a null hypothesis. We first give a claim that say the X medicine is 70% effective. Then we give an anti-claim, like this is called the alternate hypothesis, which negates this. X is not 70% effective. Correct? Then we study the sample and come to a conclusion onto which hypothesis is true. Correct? That's how we describe the population. Like we study the sample and say the average is 160 centimeter. Average is not 160 centimeter. Then we study the sample and come to a conclusion whether the population average is 160 centimeter or not. Understood? First we give the claim and then we see whether our claim is true or not. Understood? This is in our syllabus. Estimation is not in our syllabus. এত দূর বোঝা গেছে? Everyone? So basically what are we doing? We are analyzing data, correct? These are the ways we analyze data. So first we need to know what is the type of data we have, what are the types of data we have. If I ask you your height, what will you say? 160, 150, 140, something like that? Will you say A? So height, weight, this kind of data involves a number, correct? So whenever there is some quantity, like we have two people, if we stack one above the other, we can add their heights. It will make sense. This will make sense. So here mathematical operations are possible. This kind of data is called quantitative data, where we have a quantity. Understood? Now let's dive deeper. If I ask you your family size, like how many people are there in your family, what will you say? 4.3. You can say 4, you can say 3. This is also a number, you can add, correct? So quantitative data is also of two types. One is discrete, one is continuous. What is discrete? The data, types of data which can take only some specified values, not any value. Understood? And what is continuous? It can take any value. Understood? Now qualitative. Here we don't have a number. If I ask you your grades in your previous exam, you will say A, B, C, A plus, B plus, whatever be it. You won't say 3, 4, 5, right? You cannot add two people's grades, correct? So here we just have categories. So qualitative data is also called categorical data. তো কোয়ালিটেটিভ ডেটার মধ্যে দুটো ক্লাসিফিকেশন, একটা হলো নমিনাল, একটা হলো অর্ডিনাল। Say I go to a class and ask you guys your religion. Say 70 people say they belong from the X religion, Y people say they belong from 20 people say they belong from the Y religion, and 30 people 60 people say they belong to the Z religion, correct? I note this down. Someone wanted to copy this and they wrote it like this. Is this too different? No. It's the same letter, right? I just interchange these places. And the frequencies are also simultaneously interchanged. So it's no different. It's the same, correct? Because there is no sense of ordering between the categories. Understood? This type of data is called nominal data. But if I ask you your grades, say A was got by 70 people got A, B got 20 people got B, and 60 people got C. If I mess this up, now this is not making any sense, correct? So when there is some sense of ordering, there will be ordinal data. Now, why do we need to even classify this? I'll just explain this now. Coming on to diagrammatic representation. What are the diagrams do we have? We have pie chart, which looks like this. We have bar diagram. Now, these are the mostly used diagrams. There are a number of diagrams, but we use these mostly. And we have histogram. Bar diagram looks like this. There are gaps between the bars, correct? Correct? And what does the histogram look like? There are no gaps between the bars, like this. Now, which diagram are we going to use? In which case? Say, for nominal data, X 70, Y 60, Z 20. Correct? Here, there is no sense of ordering, correct? In a pie chart, can you find any sense of ordering out here? Which is the first one? You don't know, correct? Which is the second one? You don't know. So, for nominal data, we can use a pie chart. Understood? But whenever there were grades, here, if we plot it like this, A, B, and C. If we plot it like this, here we can see the sense of ordering. No, bar diagram. So for ordinal data, we have bar diagram. হিস্টোগ্রামের মেন সমস্যাটা কি বলতে, এখানে তো অ্যাক্সিস বরাবর এখানে থাকে, নাম্বারস থাকে, ইন্টারভালস থাকে, এখানে তো আপনার ক্যাটাগরিজ রয়েছে খালি, হিস্টোগ্রামের কোনো কোয়েশ্চেনই নেই এখানে। আন্ডারস্টুড এভরিওয়ান? For discrete data, example discrete data, family size, একজন রয়েছে ফ্যামিলিতে এরকম বললো 20 জন, দুজন রয়েছে ফ্যামিলিতে এরকম বললো 30 জন, and so on. ধর 10 জন রয়েছে এরকম বললো 2 জন। Sense of ordering is still present. So what are we going to use? Bar diagram. Understood? And for continuous data, which can take any value, only for that we use the histogram. Understood, everyone? So diagrammatic representation মোটামুটি মাথায় ঢুকেছে নাকি? Central tendencies. What is central tendency? I have a class of 150 or a sample of 150. I ask each of them their marks in the previous exam. Correct? I have 150 data points. If someone asks me about the performance of the class, what will I do? Give them the 150 data points. What will we do? We will try to find a middle value. So what are the different types of middle values we have? The magnitudinal center or the mean, where we add all the values and divide by the total number of values. That is mean. That is the magnitudinal center. We can have the positional center. What is that? You just arrange them in the ascending order and then find the middlemost value. Median. And what is more? The value which occurs the maximum number of times. That is more frequency. Now, when to use what? That is more important, because these everyone know what these are. Formulas you can mug up, but when to use? Say I have data like this. And the frequencies are say 20, 30, 20. Correct? Can we find the mean? Yes. Class 10 ছিল এই যে মিডল ভ্যালুটা নিতে হতো 25, 35, 45 দিয়ে এগুলো মাল্টিপ্লাই করে দিতে ভাগ করতে হতো ছিল না? It was there in class 10. We find the class marks, multiply them by the frequency divided by the total frequency. It was there. Had I written it like this, now is it possible? In these cases, we use the median. Understood? Another example of use of median. Say I have data to, like, I have asked people how much rice do they have in a day. Some people say 100 grams, some people say 70 grams, some people say 20 grams, 200 grams. And out of everyone, one guy say 1 kilo. Everyone says something like this, in the range of say 60 to 210, this range. One single guy says what? 1 kilogram. Okay, the average will spike up. If we try to find the mean, this 1 kilogram is 1000 grams. If we add that, the average will spike up. But if we find the median, say I will take 5 data points, 60, 80, 100, 120, 1000. Okay? If try finding the average, what will happen? Huh? Mean ta ber kor কত হবে 140, 2360 divided by 5, 4, 472. 472. Is this logical? Like someone is having 472 grams of rice. Is it a logical average? No. But let's find the median. So median is least affected by outliers. Understood? So these are the cases we use the median. Mode is not very widely used. It is used in when you want to know which value is occurring more. Which value is more frequent. In that cases we use the mode, else we don't. Understood? When to use what? That is more important, because the formulas are always there. Then comes dispersion. What is dispersion and why is it necessary? 2, 4, 6, 8, 10. This is a data set. 2, 3, 6, 8, 10. 8 and 9. This is also a data set. Find the average, find the median, there is no mode. Find the average and find the median. Both of them will be 6 for each case. Try finding it. Add করলে মোটামুটি 30 আরে 30 হয় রে 10 10 10 30 30 বাই 5 6 মিডিয়ান 6 কিন্তু ডেটা পয়েন্টগুলো ক্লিয়ারলি আলাদা তাই তো what's happening here? These gaps are differing, correct? These gaps are differing. So what can we do? We can add up the gaps, like 2 minus the average plus 4 minus the average plus 6 minus the average plus 8 minus the average plus 10 minus the average, and then take the average of these deviations. We can do, but what will happen? It will turn 0 every time. Every time this will be 0. Why will this be 0? Because mean is the magnitudinal center. How much low values are there from the mean, the same amount of higher values are there from the mean. Understood? So let's find this out. Minus 4 plus minus 2 plus 0 plus 2 plus 4. This will be 0 every time. Do this for that also, it will be the same. So what are we going to do? We are going to remove the negatives. How are we going to do that? We can square them. Squared. And then take the average. How many? 5. We have the variance. Understood? The formula, you know the formula variance, 1 by n summation xi minus x bar whole square. Correct? Where does this formula come from? From here. Understood? We got variance. But the main problem with variance is that how are you going to describe it? Like we have data on incomes. 5 data points on incomes. The variance will, the unit of the variance will come out to be rupees square. What is rupees square? So what can we do? We can take a square root. And call the standard deviation. Now you know where these things coming from. এবার আমার একটা কথা বল, for qualitative data, can we have a mean? Can we have a median? Can we have a mode? Arguably, we can just have a mode, nothing else. Correct? Or maybe a median, but still that won't make any sense. For this kind of data, qualitative data, we can only do frequency distributions and we can do diagrammatic representations, nothing else. For quantitative data, we can do any of this. Now, we know how to describe a sample at this point, correct? Now, what should be the desired sample size? Why are we sampling? Because it is not possible to go to everyone in the population. For what are the reasons? One, lack of time, lack of resources, lack of, which includes money also, and manpower. So these are the main reasons why we are sampling. So we had a population of 1 lakh. We take a sample of say 2 people. That would have been very cost efficient, very time efficient. But will the results make much sense? Had we taken a sample of say 50,000, that would give very reliable results, but this won't satisfy. So what is the desired sample size? There are 2 formulas for calculating desired sample size. One is our Cochrane's formula. And another is Taruyamane formula. Cochrane's formula is used when we don't know the population size. And This is used when we know population size is known. Okay. So, where are we going to take the data from? OPD. Correct? So, we know, we have an idea of how many people attend the OPD in a single day. We have a scope for 6 days. So, we can estimate, say, 100 people who attend the OPD every day. Correct? So, for 6 days, how many people are going to attend? 600. So, this is the population size. We know that. So, which formula are we going to use? This one. What is it? How is it given by? N by 1 plus n into E square. Okay. What is N? 600. What is E? The amount of error we are allowing. Look, there will always be an error when estimation, when estimating or drawing inference. Understood? There will always be an error. Because we are never actually going to the 1 lakh people, right? We are drawing a sample and then we are inferring about that 1 lakh people. So there will always be a chance of error. But how much error are we allowing? Say we are allowing 5% error. Then E will be 0.05. Understood? And this is given by for now you just know that ZE is a constant and it is given by 1.96. For E is equal to 0.05. ZE becomes 1.69 for error is equal to 0.1 or 10% error. Just keep this in mind. What is this? I'll explain later when I'll teach you testing of hypothesis, which cannot be done in a single class. Everything will just go over your heads. Understood? So when we don't know the sample size, what are we going to do? We are just going to like assume, like take a variance, like take a small sample, take the variance, put it here and then estimate the actual sample size. And Z at a constant. Z at a constant. It is a constant which varies with respect to E. For E is equal to 0.05, we have Z is equal to 1.96. For 5% error, we have Z is equal to 1.96. For 10% error, we have Z is equal to 1.69. And we have many other values which you are going to get from the standard normal table, which I am going to teach you when I am going to teach you testing of hypothesis. Understood, Atadur? Sample to draw করলাম এবার কিভাবে draw করব মানে we have the sample size, how are we going to draw the sample? Say we have a class of 150 people. I can't go to everyone, I don't have that much time. I want a sample of 10 people and like take the average of how the marks they got in the previous exam, okay, and then estimate the average marks of the 150 people. Correct? I go up to the teacher and ask him, like, give me 10 PC students. He gives me his favorite most 10, who scored the highest. The average will spike. Correct? For certain reasons, he sends the worst 10 people. Average will spike. So, what is happening here? Here is something called bias is occurring. What type of bias is this? Selection bias. Where we are introducing a bias due to our own selection. So what can we do to remove the selection bias? We can do it randomly. Like we have 150 people, we assign them numbers and then like cast a die, toss a coin and then I include them in the samples. We can do that. We can use this random number table and do sampling. We can do that. That type of sampling is called simple random sampling. That is something that should have been done in a study, but due to lack of resources, we are going to do what is called convenience sampling. What is convenience sampling? We go to the OPD and ask each and everyone, please give us your data. We do it ASAP, like the least time we can do, like, what do you say? Like the least time we can spend on getting data, we do it. We go to the OPD and just ask.